Hi everyone, welcome back to my YouTube channel. And today I'm discuss the fourth problem of today's Codeforces round 894 Division 3. And I felt like the problem D was quite easier than the third problem. But the third problem you have to think something about like that. What was the third problem? Third problem was about okay, so third question we'll discuss later, but yeah, like I felt like the fourth one is quite easier than the third problem. And in fourth problem, like this is a little bit about math. You can solve it using mathematical formula, or because I used binary search in this problem. So the problem statement is okay, so you have to to improve his ice cream making skill, and he has already learned how to make ice cream legit. Okay, so here you are given. Okay, so here Tima decide to improve his ice cream making skill, and he has already learned how to make ice cream. So here, to make ice cream you need two ball. Okay, and you need exactly two ball to make one ice cream. And okay, so two ball. And there is one condition is there. uh, like the balls have different flavor. Let's suppose I consider this thing. If you are given the number like this, that means here the number of ball is 4, but the flavor is the number of different flavor is 2, and in each flavor there exists two ball in this case, if you consider this. Okay, and similarly you can take similarly you can let in this case, see, in this case 1 2 3 4. This means the number of ball is 4 and the number of flavor is 4. And yeah, like in this problem you are given an integer n, and you have to make the exactly that number of different ice cream. You have to notice one thing, that exactly, because during contest I did not uh, read I did not read this thing like exactly. So that's why I wasted my lot of time during contest. Okay, so yeah, like you have to build exactly n different ice cream. Okay, so how you distinguish between two ice cream, that okay, so this is one, and the ice cream are not exactly same. Because you can build ice cream using balls. Okay, and exactly two ball. So just consider I am taking this ball 1 and 2, and one is 1 and 1. Okay, so these two are considered two different ice cream, because in this set, in the first ice cream, uh, the flavor is the like in the first ice cream, two different, like the two balls have two different flavor. One is 1 and 2. And in this case, in the second case, two ball have the same flavor, 1 and 1 and 1. But look this as a set. Okay, so in this set, the number of distinct values is 2, as well as the number is 2. And but in this case the number of distinct value is 1. So I mean, two set can be equal if they have equal element. Okay, equal element means like order doesn't matter here. See, the 1 and 2 and 2 and 1, these two are equal. Okay, 1 and 2, 2 and 1 are equal. But 1 and 1 is not equal to 1 and 2, is not equal to 2 and 2, right? So in this set you have two element uh, with flavor value, both, like the flavor value of both the element is equal, that is 2. And in this case, flavor value of both the element is different, like one for first one is 1 and for second one is 2. And in this case both are having same flavor, but flavor value is 1. So I mean, two ice cream you can distinguish between two ice cream if the two set does not contain any, like two sets are not same. and don't consider as don't consider, like, don't think about any kind of error, like any kind of order in this case. So it is better to look this thing. For example, the set, these two set are same and these two set are different. So in this case you can say that this is one ice cream, single ice cream, and in this case this is two ice cream, right? So yeah, like in this way you can distinguish between two ice cream, and you have to tell what is the minimum number of ball you need to make exactly in different type ice cream. Just focus on this thing in exactly. And okay, so like this is the problem statement and you have to tell the minimum number of ball. So how will you supposed to approach this problem? If you like if you have done this kind of problem, see, so if I get, like, if I take the ball like this, so basically the observation is more the number of distinct flavored ball, more the number of ice cream. This is the observation. Like after that everything is math. Okay, so how you gonna calculate the number of distinct flavor? So that is like, for that you can, I think for that we have to use binary. So I don't think we have any other option. So and also the time complexity also, like it also satisfied 10 to the power 4, and for binary search it is 60 at worst case, because 10 to the power 18, and if you take like log of 10 to the power 18 which is equal to 60, so it is the overall time complexity will be 10 to the power 5 or 10 to the power 6, in between 10 to the power 5 and 10 to the power 6. So yeah, like the first observation is that more the number of different flavored ball, more the number of ice cream. So yeah, so just consider this thing. So like we'll take a simple example, not longer, like not big example. Just consider these three flavored ball. So in this case what is the like what is the number of different ice cream can you can make? The number of different ice cream can be 1 and 2. 1 and 2 will make one ice cream, and 1 and 3 will make one ice cream, and 2 will 3 make one ice cream. So in this case the number of different ice cream can be 3. But if I take one twice, then what will happen? If I take one twice, for say for this one, this is the case, this is case, uh, it is bet like, okay, so just take another example. It is this is the like important thing in this problem, so you just understand this part carefully. uh, I'll just take another example, right? So 1 2 4 5, oh sorry, yeah, uh, 1 2 1, okay, 1 2 3 4 5 6. So you just took this number of balls, and all the ball have different flavor. So what is the maximum number of ice cream you can make? Is, for this case, you can pair this number with all other what? Uh, okay, yeah, you can pair this number with all other ball, right? So in that case, 1 2 3 4 5, the number is 5. And for this one you cannot pair with 2 with 1, because we have already considered 1 2 as a pair. So we cannot consider 2 1 as a pair, because 1 2 and 2 1 are not different. 1 2 and 2 1 are same. So 1 2 and 2 1 are same as, okay. And for 2 the number will be, because 2 can pair with 3 4 5 6, right? So the number is 4. And for 3 it can be 3 can pair with 4 5 6, so the number is 3. And for 4 it is 2. And for 5 it is 1. And for 6 what is, for 6 is nothing. 5 for 4 it is 2 and for 5 it is 1, and this number is exactly equal to 6 by 6 into 5 by 2, which is equal to 15. Is it 15 or not? 5, 5, yeah, it is 15. So if I replace some of the number with equal value, let's just replace this one. Sorry, let's just replace this 2 with 1 and this 4. This okay, so this 3 with 4. Replace this 3 with 4. Actually, what does it mean? Like these are like, you can consider this as a single ball, this is single ball, this is single ball, but the flavor are the like, oh, here we are distinguish this ball with flavor. These two ball have same flavor, these two ball have same flavor. So here I'm trying to say is, if you have the ball, if you have the same flavored ball more than one, then you are going to decrease the number of ice cream. Like, yeah, you are going to decrease the number of ice cream. So that is my point. Yeah, like you can see it here. See, just a second. Mm, we can see it here. Just a second. For one, it can pair with how many number? For one, it can pair with uh, for it can pair with this 4, this 5, this 5. Okay. Uh, mhm. For it can pair with this one, this one, this one, 3, and for 4 it is distinguished number 2. And one more thing, that at first you just forget about that there exists some duplicate element in this set. Okay, so just calculate as normal way, but and the way that I have calculated previously. So just calculate answer for similar way. For the one, just consider the number of distinct value 3. Okay, yeah. And for 4, the number of distinct value right now the number of distinct value is 5, 2, because I'll not consider the values before 4. And for 5 it is 1. Now just consider about the duplicate value, because the duplicate value 1 can only be paired with this one, right? And the 4 can only be paired with this 4, because 4 cannot pair with 5, because I have already considered 4, 5, because I have already made one ice cream taking 4 and 5. There is no point of taking 4 and 5 again, because here we are taking 4 and 5 again due to duplicacy, but there is no point of taking. So in this case the answer is 1 for this duplicate value 1, and for this one answer is 2. So overall this is 2. And if I take again 1, then like this is the, like this is kind of wastage of ball, wasting of ball. So yeah, like, because if I take 1, then one cannot pair with any one of the ball. So for this is kind of like wastage. So I think, yeah, like it is optimal to take as many as different flavored ball, so as to reduce the number of ball. Okay. And and one thing that you can notice, that every time, like your answer, this is your number, second. So now see, you want to build six number of ice cream, but here n into n minus 1 by 2. This formula, uh, I have uh, I, I have told you like how this formula came in this previous answer. Like this is the this is the formula for what? This is the formula for if we have total, if we have all the, if we have like all the ball in our set, has have different flavor. Okay, so for that, this is the formula. What is the maximum number of ice cream that we can make? So at first we are just trying to take as many as of distinct values, and if we require, then we'll take what then we'll take uh, then we'll take duplicate value, because because we will need the duplicate value in future. So in this case, we are just trying to find the value of n. So what is the suitable value for the n is that in this case the value is 4 into 3 by 2. Yeah, if the value of n is 4, this is 4 into 3 by 2, which is 6. But every time you'll not get an integer value for n. Okay, so at that case what we can do is, mm, just take the example of let's just take the example of 8. N value is 8. Sorry, ice cream value is uh, ice cream value is 8. Ice cream value is 8, and you have to find, at first just try to find uh, maximum number of what is the maximum number of different what is the maximum number of different flavored ball I can take. So just use this mathematical formula. In this case, if you take this is just 4 into 3 by 2, this is 6. So now I can just take 5 and 4 by 2. This is what this is 10. So this value, if I take 5 distinct flavored ball, then my answer is exceeding the required answer. So the number of ice cream is exceeding the number of distinct sorry the number of ice cream is exceeding the number of required ice cream. So because we do not we have to make exactly n different ice cream now, so this is not gonna be our answer. But yeah, like here in this case, we can take n as a 4. Why? Like in the 4 case, 4 into 3 by 2. In this case, the value is 6, and we can make by taking four different flavored ball, we can make 6 ice cream. Because we have to okay, so we can make 6 ice cream, but we have to make 8 ice cream, 2 more extra. So for that, like in this case, we have to use duplicate. And duplicate, how much duplicate? Then how much duplicate? The number of duplicate value should be 2. Okay, so in this case, I can explain the above one by taking example. See, for 4, because we have to make 8 different ice cream. So if we take this, if we at first we take 4 ball with four different flavor ball, and these guys make 6 different ice cream. And if I just adding one more ball with different flavor, then the answer is 10, which is exceeding my required answer. So I cannot take any ball with the flavor which is different than the existing one. If I take, then it will exceed our answer. So in this case, I have to take I have to take the I have to add one or more than one ball, but the flavor of the ball should be same as the one of the flavor of the ball should be same as the existing ball's flavor. I mean it. I mean it. I mean it can be same with any. Yeah. I mean it can be same with any one of the existing ball. The flavor of upcoming ball should same with any one of the existing ball. Okay. So yeah, like if I in this case I just have to add one more one, and if I just adding one more one, then there is no point of adding 1 because yeah, like why we are not interested in three ball with same flavor, because there is no point of like taking three ball with flavor, because two balls we can do the same work with two ball. So why we are increasing the number of ball? Because in our answer we have to decrease the number of ball, so there is no point of taking three ball. But yeah, like we are going to take the two balls, and this will increase my answer by one, because it can only contribute with it can only paired with this one and one, because it cannot pair with any one of the answer, because for this one I have already considered the all the pair. Okay, so it can only pair with the like pair with this one, and it increase my answer by one. And also I have to take another ball which is similar, with the flavor of that ball should be same with the existing one. And existing here you take the ball with having the flavor is one, and in this case you have to take the ball with flavor two. So yeah, it will increase my answer by one. And in this case you will get your like total number of ice cream is 8. So yeah, like this is the whole answer. And one more thing is that, okay, so just try to find the number in this case, because how like because you are not because you did not know what is the n value. So to calculate the n value you have to use binary search. Like if you guys solve the problem, like if you guys know how the square root function work, like that stl square root, like sqrt, what is the implementation, internal implementation of that square root function, then I think you can easily relate this thing, this part n into n minus 1 by 2, how you can how you're gonna calculate this part, because that square root like internal implementation is done with the help of binary search. Okay, yeah, like I can show my code for this problem, because this was the whole solution for this problem. Just find n, and like that n should satisfy the condition that n into n minus 1 by 2 should be less than or equal to n value. Sorry, okay, so should be less than equal to ice cream value. Yeah, after finding that you just try to find what is the what is the how much more, sorry, what is the additional, how much, yeah, like after finding this value you have to calculate uh, after calculating this value you just have to subtract the n value within the answer into answer minus 1 by 2, and just add this value to your answer. That is your final answer. So this is the whole solution. And why you are going to do this, uh, because this thing will tell you what is the amount of number you have to add, that will make your that will help you making exactly n number of different ice cream. That will help you making this number. So just let's just go through the code, like what I have implemented. I have implemented the same thing, that whatever things I have told you, I just implemented the same. Here I took the input n, and here I did the binary search to calculate that answer value, because answer into answer minus 1 by 2 should be less than equal to n. Okay, so after finding that I just find this n into this value, and this is the answer, right? Yeah. So this is the whole solution for the fourth problem. If if you have any doubt you can ask me in the comment section. ओके सो मिलते हैं नेक्स्ट वीडियो में.